Okay, so now I'm going to be working question number 100, still from worksheet 10.7. It says, what mass of ammonium chloride must be added to 0.750 liters of a 0.100 molar solution of ammonia to give a buffer with a pH of 9.26? And so I've just written out some data here. The problem gave me the volume, gave me the molarity, and it gave me the pH. And I just went ahead and calculated the molar mass of ammonium chloride because I'm going to need that in a minute. So as with almost all buffer solutions, where do we start? Rice. So NH3 is going to react with water to give me NH4 plus OH minus. So another thing I'm going to have to deal with is this pH, because I don't have hydrogen ions, I have hydroxides. So I need to convert the pH to pOH. So 14 minus 9.26 equals 4.74 is my pOH. And if I take 10 to the negative 4.74, that will give me my hydroxide ion concentration. So let's do that on the calculator so you can see it. So we're going to hit the second button. We're going to hit the log button because I want that 10 to the x. Then I'm going to hit the negative sign, not the minus sign. And then I'm going to put in this answer that I just calculated. Equals, and I get 1.82 because it looks like, well, my pH only has two significant figures, so 1.8 times 10 to the negative fifth. And that's my molarity of hydroxide ion concentrations. And this is what it's going to be at equilibrium, right? So I start here with 0.100. I'm going to lose X here. I don't care about water. We never deal with water because its molarity is so huge. It's like 56 molar. It's just not used. I start with 0 here and 0 here. I'm going to lose X. I'm going to gain X. I'm going to gain X. And I get 0.100 minus X. Now this is X, but here they tell me what I want that to be. They tell me I want that to be 1.8 times 10 to the negative fifth molar. Now here, oh, and we need the Kb for ammonium. And I don't think I have that number right here. I will have to look. Oh, wait, here it is. 1.8 Kb equals 1.8 times 10 to the negative fifth. Okay, so I have my Kb. And I have this equation. Since this number is pretty small, I'm going to go ahead and ignore X. And you say assume X is very small compared to 1.00. And so Kb, which equals 1.8 times 10 to the negative fifth, is going to equal X times 1.8 times, 1.8 times 10 to the negative fifth. And then divided by the original concentration, 0.100. Oh, these two numbers are the same. That's interesting. So I'm going to get 1.8 times 10 to the negative fifth times 0.100 divided by 1.8 times 10 to the negative fifth. So this cancels with this, and that's going to equal X. So X equals 0.100 molar. And that equals the concentration of NH4Cl. So now we know our volume. So I'm going to come back here to volume. And molarity equals moles divided by liters. So molarity times liters will give me my moles. So I'm going to start with my volume, 0.750 liters, NH4Cl. And then my molarity is 0.100 moles for 1 liter. And then my molar mass was, for 1 mole, it's 53.492 grams. So, .750 times 0.1 times 53.492 equals, I get 4.0119 grams of NH4Cl. And I had 2 significant figures here, so I can only have 2 of my answers, so it's going to be 4.0 grams of NH4Cl needs to be added. Hopefully that's helpful for you. I have a couple more videos to make, so stay tuned. See you later.